Hello, welcome back. In our last video, we have done t-test. Okay, our two samples t-test. However, let me just start writing. However, t-test is a parametric test. Okay, which means that there is a requirement or there's an assumption. It requires that the data is normally distributed. And how do we test for normal distribution? We can test for normality using our Shapiro-Wilk test we have seen before. So let's look at that. Okay. Let's repeat our t-test for unequal variance. Okay, so let's repeat this. Our t-test for unequal variance is here. So we want to look at whether is the average glycosylated hemoglobin for diabetes or for obese equals to the average glycosylated hemoglobin for not obese. Okay, so these are our t-tests, and we find that we reject the null hypothesis. That means the average glycosylated hemoglobin for obese patients is significantly different from the average glycosylated hemoglobin from not obese patients. However, let's look at, can we actually use t-test here? So we use Shapiro test and we check for glycosylated hemoglobin. Okay. Now, it gives you a very low p-value. It's less than 2.2 times 10 to the power of minus 16, which means that the glycosylated hemoglobin is not normally distributed. So if that is the case, by right, our t-test is actually invalid. So what can we do? Is there an equivalent of t-test that does not assume equal variance? Yes, there is. This test is known as your Mann Whitney U Test. Okay, this is actually the non-parametric equivalent of t-test, two samples t-test. Okay, now if it's not normally distributed, then equal or unequal variance doesn't make a difference at all. There's no such thing. Okay, so Mann Whitney U test is also known by a few names called Mann Whitney Wilcoxon Test. Okay, also known as your Wilcoxon Rank-Sum Test. So there are a few names. They are actually the same thing. So how do we do that? Okay. Remember, what we did is our t-test. This is our t-test. Use the same syntax, but the t just change to Wilcoxon, not the full name. Okay. Yep, there you have it. Okay, you still reject the null hypothesis. Okay, which means that the average glycosylated hemoglobin for obese patients is not equal to average glycosylated hemoglobin for not obese patients. So let's look at it. Oops, just try a little bit. Yep. So now you get these two values. Okay, this is from the parametric t-test. This is not the from non-parametric version. And how you actually do it is actually very simple. This is the t-test assuming unequal variance. Just change the name to Wilcoxon and you remain everything the same. That will be your non-parametric t-test. All right, so then the next question you'll be asking, what happens for our paired t-test? That will be the subject of next video. See you.